Machine learning (ML) is the study of computer algorithms that can improve automatically through experience and by the use of data. It is seen as a part of artificial intelligence. Machine learning algorithms build a model based on sample data, known as training data, in order to make predictions or decisions without being explicitly programmed to do so. Machine learning algorithms are used in a wide variety of applications, such as in medicine, email filtering, speech recognition, and computer vision, where it is difficult or unfeasible to develop conventional algorithms to perform the needed tasks. A subset of machine learning is closely related to computational statistics, which focuses on making predictions using computers, but not all machine learning is statistical learning. The study of mathematical optimization delivers methods, theory and application domains to the field of machine learning.
Data analysis through unsupervised learning. Some implementations of machine learning use data and neural networks in a way that mimics the working of a biological brain. 7-8. In its application across business problems, machine learning is also referred to as predictive analytics. Learning algorithms work on the basis that strategies, algorithms, and inferences that worked well in the past are likely to continue working well in the future. These inferences can be obvious, such as, since the sun rose every morning for the last 10,000 days, it will probably rise tomorrow morning as well. They can be nuanced, such as, X% of families have geographically separate species with color variance, so there is a Y% chance that undiscovered black swans exist. Machine learning programs can perform tasks without being explicitly programmed to do so. It involves computers learning.
For more advanced tasks, it can be challenging for a human to manually create the needed algorithms. In practice, it can turn out to be more effective to help the machine develop its own algorithm, rather than having human programmers specify every needed step. The discipline of machine learning employs various approaches to teach computers to accomplish tasks where no fully satisfactory algorithm is available. In cases where vast numbers of potential answers exist, one approach is to label some of the correct answers as valid. This can then be used as training data for the computer to improve the algorithms it uses to determine correct answers. For example, to train a system for the task of digital character recognition, the MNIST dataset of handwritten digits has often been used. The term machine learning was coined in 1959 by Arthur Samuel, an American inventor and pioneer in the field of computer gaming and artificial intelligence.
Also, the synonym self-teaching computers was used in this time period. A representative book of the machine learning research during the 1960s was the Nielsen's book on learning machines, dealing mostly with machine learning for pattern classification. Interest related to pattern recognition continued into the 1970s, as described by Duda and Hart in 1973. 16. In 1981, a report was given on using teaching strategy so that a neural network learns to recognize 40 characters, 26 letters, 10 digits, and 4 special symbols from a computer terminal. Tom M. Mitchell provided a widely quoted, more formal definition of the algorithms studied in the machine learning field. A computer program is said to learn from experience E with respect to some class of tasks T and performance measure P if its performance at tasks in T, as measured by P, improves with experience E. Tom M. Mitchell provided a widely quoted, more formal definition of the algorithms studied in the machine learning field.
As a scientific endeavor, machine learning grew out of the quest for artificial intelligence. In the early days of AI as an academic discipline, some researchers were interested in having machines learn from data. They attempted to approach the problem with various symbolic methods, as well as what was then termed neural networks. These were mostly perceptrons and other models that were later found to be reinventions of the generalized linear models of statistics. However, an increasing emphasis on the logical, knowledge-based approach caused a rift between AI and machine learning. Probabilistic systems were plagued by theoretical and practical problems of data acquisition and representation. Machine learning (ML), reorganized as a separate field, started to flourish in the 1990s. The field changed its goal from achieving artificial intelligence to tackling solvable problems of a practical nature. It shifted focus away from the symbolic approaches it had inherited from AI,
and toward methods and models borrowed from statistics and probability theory. Machine learning and data mining often employ the same methods and overlap significantly, but while machine learning focuses on prediction, based on known properties learned from the training data, data mining focuses on the discovery of previously unknown properties in the data. This is the analysis step of knowledge discovery in databases. Data mining uses many machine learning methods but with different goals. On the other hand, machine learning also employs data mining methods as unsupervised learning, or as a pre-processing step to improve. Machine learning and data mining often employ the same methods and overlap significantly, but while machine learning focuses on prediction, based on known properties learned from the training data, data mining focuses on the discovery of previously unknown properties in the data. This is the analysis step of knowledge discovery in databases. Machine learning also has intimate ties to optimization. Many learning problems are formulated as minimization of some loss function on a training set of examples. Loss functions express the discrepancy between the predictions of the model being trained and the actual problem instances. For example, in classification, one wants to assign a label to instances, and models are trained to correctly predict the pre-assigned labels of a set of examples. The difference between optimization and machine learning arises from the goal of generalization. While optimization algorithms can minimize the loss on a training set, machine learning is concerned with minimizing the loss on unseen samples. Characterizing the generalization of various learning algorithms is an active topic of current research, especially for deep learning algorithms. Machine learning and statistics are closely related fields in terms of methods but distinct in the core objective of a learner is to generalize from its experience. 429. Generalization in this context is the ability of a learning machine to perform accurately on new, unseen examples, tasks after having experienced a learning data set. The training examples come from some generally unknown probability distribution, considered representative of the space of occurrences, and the learner has to build a general model about this space that enables it to produce sufficiently accurate predictions in new cases. The computational analysis of machine learning algorithms and their performance is a branch of theoretical computer science known as computational learning theory. Because training sets are finite and the future is uncertain, learning theory usually does not yield guarantees of the performance of algorithms. Instead, probabilistic bounds on their performance are quite common. The bias variance decomposition is one way to quantify generalization error. Unsupervised learning algorithms take a set of data that contains only inputs, and find structure in the data, like grouping or clustering of data points. The algorithms, therefore, learn from test data that has not been labeled, classified or categorized. Instead of responding to feedback, unsupervised learning algorithms identify commonalities in the data and react based on the presence or absence of such commonalities in each new piece of data. A central application of unsupervised learning is in the field of density estimation in statistics, such as finding the probability density function. Semi-supervised learning falls between unsupervised learning, without any labeled training data, and supervised learning, with completely labeled training data. Some of the training examples are missing training labels, yet many machine learning researchers have found that unlabeled data, when used in conjunction with a small amount of labeled data. Rule-based machine learning is a general term for any machine learning method that identifies, learns, or evolves rules to store, manipulate or apply knowledge. The defining characteristic of a rule-based machine learning algorithm is the identification and utilization of a set of relational rules that collectively represent the knowledge captured by the system. This is in contrast to other machine learning algorithms that commonly identify a singular model that can be universally applied to any instance in order to make a prediction. Rule-based machine learning approaches include learning classifier systems, association rule learning, and artificial immune systems. Inductive logic programming (ILP) is an approach to rule learning using logic programming as a uniform representation for input examples, background knowledge, and hypotheses. Given an encoding of the known background knowledge and a set of examples represented as a logical database of facts, an ILP system will derive a hypothesized logic program that entails all positive and no negative examples. Inductive programming is a related field that considers any kind of programming language for representing hypotheses, and not only logic programming, such as functional programs. An AN is a model based on a collection of connected units or nodes called artificial neurons, which loosely model the neurons in a biological brain. Each connection, like the synapses in a biological brain, can transmit information, a signal, from one artificial neuron to another. An artificial neuron that receives a signal can process it and then signal additional artificial neurons connected to it. In common AN, decision tree learning uses a decision tree as a predictive model to go from observations about an item, represented in the branches, to conclusions about the item's target value, represented in the leaves. It is one of the predictive modeling approaches used in statistics data mining, and machine learning. Tree models where the target variable can take a discrete set of values are called classification trees. In these tree structures, leaves represent class labels and branches represent conjunctions of features that lead to those class labels. Decision trees where the target variable can take continuous values, typically real numbers, are called regression trees. In decision analysis, a decision tree can be used to visually and explicitly represent decisions and decision-making. In data mining, a decision tree describes data, but the resulting classification tree can be an input